Have you ever interacted with an application that just seems to forget who you are or what you were doing the moment you navigate away, or even when you simply refresh the page? It can be frustrating when systems do not remember context, and sometimes, designing a completely stateless server is precisely what causes that experience. You should generally avoid a purely stateless server implementation when your application inherently relies on maintaining user or session-specific information between requests that cannot be easily externalized or recreated. This happens when the cost or complexity of externalizing state outweighs the benefits of statelessness, or when a continuous, uninterrupted user interaction is absolutely critical. The core reason is that a truly stateless server processes each request independently, without knowledge of any previous interactions. While this offers tremendous benefits in terms of scalability and resilience, it means any information needed for a user's session, such as a shopping cart, login status, or an ongoing multi-step form, must be stored externally. When this external state management becomes too cumbersome, introduces unacceptable latency, or creates single points of failure, the stateless model can introduce more problems than it solves. Imagine building a real-time multiplayer game where every server needs instant, synchronized knowledge of all player positions and actions. To decide if you should avoid statelessness, evaluate your application's specific requirements. First, identify if you have long-running, interactive sessions that requiring continuous context. Next, consider the nature of your data. Is it frequently updated and deeply interdependent, or can it be easily partitioned and stored in a shared, external data store like a database or a caching system? Finally, assess the performance and latency implications of constantly retrieving or updating this external state for every single request. If these factors point to excessive overhead or a fractured user experience, then a more stateful approach or a hybrid model might be more suitable. For example, consider the intricate dance of a database transaction. While the web server itself might be stateless, the database managing multiple concurrent transactions is inherently stateful, ensuring data integrity across complex operations. In such cases, trying to force the transaction logic into a purely stateless server model would be an architectural nightmare. Another example is a legacy system with deeply embedded session data that is prohibitively expensive to refactor. Knowing when to deviate from the stateless ideal is key to pragmatic, effective system design, acknowledging that even the most modern architectures often have stateful components lurking underneath. Ultimately, the decision to avoid a purely stateless server hinges on understanding your application's unique need for persistence, continuity, and real-time data access. If externalizing session data introduces unacceptable complexity, performance bottlenecks, or compromises critical user experience, then embracing a controlled, stateful, or hybrid approach can lead to a more robust and efficient system that truly serves its users.
If this helps you code smarter, like, subscribe, and stay tuned for more.